Hello everybody. Today we'll talk about running neural networks on the edge. To do that, we have to be power efficient. We will show how to optimize memory management for power efficiency. After introducing the problem, we will present two concrete issues of memory management: tiling and forwarding, and filters management. Then we will have a look at modern convolutional neural networks and see how memory management applies. If you're watching this summit, you're probably aware that power consumption is a big deal for inference on the edge. Power consumption has two components. The first one, compute power, is the amount of energy you have to invest to run those arithmetic computations which you have so many of. The second component is I/O power. That's the amount of energy that you need to invest in order to bring the right data to at the right time to the right computation engine so that those computations can happen. When doing CNN inference, you have to be particularly aware of I/O power, because it can be even higher than compute power, and this is why the compiler has to optimize memory management. During this talk, we will focus on CNNs, we will focus on convolutions, although these are not the only layers, these are pretty representative. We will assume that the network is fixed and quantized and pruned if it is necessary. And we will only talk about inference. What's a convolution? A convolution takes two inputs. The first one is an input feature map, which is basically a 3D rectangle of data. The second input are the filters, which are part of the description of the convolution. Once you apply those filters on the input feature map, you get an output feature map. You can do that with many kinds of accelerators: CPU, DSP, GPU, NPU or TPU, and those have most of the time multiple cores and multiple levels of memory. Those are pretty complicated.